Hi, my name is Fred Sandblom with the Designcenter product marketing team. In this tips and tricks session, we will be having a look at assembling components more efficiently by utilizing the magnetic snap functionality. Magnetic snap is a great usability improvement that will make your workflow more efficient and streamlined while creating assemblies. So let's dig in and show the great magnetic snap functionality. In this example, we will be looking at the limited area of an electric gear motor, and more precisely, the actual junction box assembly. We make the electric gear motor the displayed part, as it is the assembly level where we want to add the required constraints. Here, a colleague has added the parts needed, scattered, and our task is to create the appropriate assembly constraints and position the electric junction box and its components properly. To compare and really show the benefits, we start by adding constraint by constraint using the traditional way and manual match phase pairs. First, we manually create a touch constraint for the bottom of the casing. We continue by aligning the mounting holes to the intended corresponding faces. In the Assembly Navigator, we note that 3 manually defined assembly constraints are created. To demonstrate the magnetic snap functionality and compare, we undo to get rid of all the assembly constraints we just created. We again evoke the auto-align function and turn on the prefer center axis over object option. That enables to snap to the axis of objects regardless of face selected. We then simply move our cursor over the component and the object to be positioned. Press and hold the left mouse button while dragging the component to intended position. In this case, we drag it to the mounting screw hole face of the motor casing. The target face lights up and the component snaps to its new position. Releasing the mouse button creates the desired constraint. Note that the system smartly finds 2 constraints and adds them. We will get back to the details on this behavior shortly. We continue by aligning the holes on the other side as well to fully constrain the junction box casing. In the same way, we constrain the top cover by simply dragging the mounting hole face to the matching screw hole face. Note that 2 constraints are created. To fully constrain, we align the hole on the other side as well. While positioning the screw to the mounting hole, we will dig a bit deeper to the functionality of the magnetic snap. Depending on where you select on the cylindrical face, at the ends or in the center, you will have different results. Let's have a look at how that works. If we grab the screw at the bottom end of the cylindrical face and drag it into the desired position, the system will create 2 constraints locking it to the entrance of the destination hole. We undo and grab the screw at the center of the cylindrical face and drag it into its desired position. This will create a single touch constraint, and the screw can still rotate and move in the actual direction of the hole. We undo again and grab the screw at the top end near the head and drag it into its desired position in the mounting hole. Note that 2 constraints are automatically created with the smart finding of the system. As there is no screw component for the other hole, we simply press and hold the control key while dragging the component to first a new rough position and then to its final constraint position. You can actually do this in one go if you want. As there is no cabling here, we need to plug the incoming and outgoing holes for the electrical cables. Looking closer to the cap, the shape indicates that we need to be careful what entities we select for the dragging. We select the cylindrical face at the bottom and drag it into the intended position. Assessing the constraint shows that it's not positioned the way we require. Hence, we undo and redo the drag operation with a more strategic cylindrical shape of the head of the cap while dragging. Assessing the assembly constraints shows that it's now constrained correctly. We repeat for the final cap, and now the assembly work is done for the electric junction box. In today's tips and tricks session, we've explored the magnetic snap functionality within the auto align function in Designcenter and the great usability and efficiency that it brings to assembly work. Dragging and dropping components based on phase pairs and the smart creation of relevant additional constraints greatly speeds up the assembly process. The control key option, while utilizing drag and drop under auto align, helps to quickly create copies on the fly and position them in one go as well, if you like. This concludes this tips and tricks session, and I would like to humbly thank you for your time and attention.